Good afternoon to you. Welcome to the show. My name is Alex MacPhail. This is High Performance Teams, and wow, have we got a high performance team for you today. Thomas Wilhelm is the local chief test pilot at Airbus in Toulouse. Test flying is a wonderful, complex operation with a very, very involved team with high-tech computers. It's going to be a wonderful conversation. It's high performance teams all the way, so please stay with us for this conversation. Hello, Thomas. Good afternoon. Welcome to you. How are you today?
Hey, good afternoon, Alex. I'm doing very fine. Thank you very much.
I know you're busy this morning. You did an RTO test. I heard the boss calling in the background. There's another meeting. So you guys are going flat out. Thank you so much for your time today. I really appreciate it.
Yeah, when I get the call from your former colleague from Tony, I was more than happy to join you, and I saw your last sessions, and it was very nice. It's interesting for me as well, so it's a pleasure for me to be on your show.
Oh, wonderful. You have some fellow Germans on the show too, and they've greeted us already. So let's just start back from the beginning. So I know you told me before, we were chatting the other day, your father was involved in gliding and light aircraft flying, but you as a teenager, you didn't show much interest at that point. But then shortly after finishing school, you did your compulsory service with the Army, and was it the parachute division that you got involved in?
Yes, you're right. So that's sometimes the history is a little bit funny or strange. So my father was involved after the Second World War, of course, where not much was going on in the initial gliding clubs in Germany, in southern Germany. So it was his great ambition. But finally, he did something completely different in his work. And when I turned about 14 or 15, I can't remember exactly, he offered me to go gliding. So we did it once or twice. I enjoyed, but it did not trigger the urge to go flying permanently. And I had a lot of other things on my head. Of course, I was playing tennis in a club, in a team, and of course, girls start to become interesting at this time. And so I didn't want to spend my weekends in a glider club, which is the case in small clubs. And so I stopped the interest in flying for some time until I joined the military for the mandatory service. And I decided if I go to the military, I do it properly. And then I joined the parachutists. And it was a good occasion to fly sometimes, but the bad thing was we had to jump out, which is good if you have to do it for 15 months. It's interesting time. Sure. Because you have a lot of exercise, you have a lot of things to do and not sitting around. But at the end, I tried to join the Air Force and I applied for the job, and finally I got it.
Okay, so let's just pause there a minute. So the Air Force application and the process in Germany, or certainly at the time you were involved in the 1980s, you were pre-screened to be able to complete your engineering training too. Do all Air Force pilots have to go and do an engineering degree first, or is that just if you are eligible for that sort of stream of flying?
So first, what you have to do when you become a pilot, you have to do the officer test. So if you manage to do that well, then you have the chance to become a pilot and go to university at the same time. So at my time, it was in '86 when I applied for that. It was about 20 people being granted per year to get university and pilots training afterwards, and the rest was about, I think, 2,000 pilots applied for the job, and 400 would have been taken. So only 20 out of 400 would have become the chance to go to a university.
Okay, so you were selected, you went to university, you completed your pilot's training as well, and obviously you took something easy like a Masters of Aerospace Science. I mean, that's just a walk in the park, that kind of work.
It's not a walk in the park, but to be honest, we have in Germany, we are in a very lucky situation. We have two fully civil accepted universities where you can do nothing else and just doing your study like anybody else outside. But you don't have to care for money. You're fully paid by the government. You are a small group. In my area, we were 80 people per year, and it was divided in aerospace science, in weapon technology, and in car technology. So in aerospace science, we were 18 people only. And if you do a university study at this, it's really possible to do something like that. You have small groups. It's easy to learn. You have always access to the professors and such like that. So it was, of course, not easy, but it was really manageable.
Sure. Look, I know some people that have done this kind of training, and they're generally a very smart group of the population that ended up doing aerospace sciences, and certainly at the Masters of Science level, Okay, so at that point now you qualify and you are eligible or streamed or suggested that you would be in the fighter line. And not uncommon to a lot of fighter pilots that I've met, if you are facing down the opportunity of a career in the fighter lines, flying jets, but no possibility of actually using these jets, it's just training, 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 it doesn't sound so appealing to you. So you wanted to experiment with the more operational type of flying, and you requested a transfer over to the transport flying. So take us from there then. How does your career map out from that point?
Well, that was interesting. So I had a good friend. We were at the university together from the same group, pilots and being engineers, and we both decided to meet our HR officer and went there and asked to being transferred to the transport. And my friend was selected first because he wrote the letter first, and he asked me if I would be willing to become a helicopter pilot. And I said, well, helicopters, you can do rescue things, it would be okay, but I would prefer to go in the transport world. And finally, I was being granted to go to the transport selection as well. And so our school was in Bremen with Lufthansa school. So the military was part of the Lufthansa school, and it still is, and it's a 2-year course. They reduced it now, I think, to 15 or 16 months. And it's with all the theory exactly the same as Lufthansa does. And then you join the military transport squadron to do your initial type rating, which was for me the Transalt, the C-160 Transalt.
Oh, wonderful aeroplane too. And I know you got involved in sort of the squadron level testing and lots of operational flying. And later on, with your background and having done the engineering degree, you selected and you completed your test pilot training in Ingolstadt and then through the ETPS school in the United Kingdom. Tell us about that briefly. I know we've got a time constraint today, but briefly tell us about the training and becoming a test pilot.
So don't worry about the time constraints. I deleted all the meetings, so I'm fully available until the end of the show. No worries with
okay.
that. So how it becomes usually, one of the necessary things is to have an engineering degree in Germany, and then we made a selection. So some people applied for the job, and I was lucky enough to get it. And then, of course, there's always a lot of money involved when you have to go to an international test pilot school. We had 4 at the time, 2 in America, 1 in UK, the Empire Test Pilot School, and 1 in France, the EPNA. Of course, you have to get the budget. So since this was not clear when we will get it, we launched our own B course to become a Class B test pilot in Manching, and we still had the aircraft to do that. So we rented the small aircraft from the flying club. We had some support from a Tornado squadron, from the Phantom squadrons as well. So they supported us in doing some training on that. So I had a chance to become a B pilot already in Manching in the year 2000. And finally, for 2002, we get the budget, and they sent me to ETPS in the UK, which is in the south, close to Salisbury.
Okay, I visited a friend who was completing his training there very recently in the last few months. That it's a lovely part of the world, and I'm sure a wonderful experience to be part of that. But now you're a qualified test pilot, and very soon after that you are selected and part of one of the lead in the Airbus A400M. So before we discuss the A400, let me put this little video clip, a bit of a teaser on the A400.
Lovely airplane, is it happening?
Well, I'm sure seeing pictures of the A400M, what an opportunity. Let's take a moment to explain this to us, please, Thomas. This is one of those opportunities. Not only do a lot of people aspire to become test pilots, but then you're selected and you qualify as a test pilot. Not only that, but you get the opportunity to be involved in a brand new airplane. Well, that's what it's all about, being a test pilot. Explain those thoughts.
Yeah, this is really a unique chance, I think, because, you know, military programs are not set up and launched very often. And for me and my colleague as well, the same colleague who joined Transport Squadron with me, he's now a test pilot for Airbus as well in Hamburg. So we really followed up each other the whole career. And it's just a great chance. So when we came back in 2003, the contract was signed and we were really available from the beginning. I was the project pilot and my friend was my deputy to follow this project from the beginning until certification, until we both then left. And the good thing in this aircraft, this was really a new aircraft in many aspects. First, it's the biggest propeller aircraft in Europe. Only in Russia, in the eastern parts, they have these big engines. We have 10.5K horsepower, 10,500 horsepower each engine, and this has to be transferred to the propeller. So that's one challenge. The good thing is, as soon as you apply power, you have lift immediately over the wings, which is a great capability, and which was one of the reasons to choose a propeller aircraft instead of a pure jet engine. If you compare to the C-17s, they have a direct lift control, blowing some air from the engines over the wings. With the propeller, we do not have to do that. So it gives us a very good slow flying capability. And being at the core of this development was just exceptional. So it was decided that we do a combined certification in the civil world. So we followed all the CS25 requirements as any civil aircraft, except when we need exemptions. So I was finally subcontracted by European Certification Agency to do the civil certification. And I did all the certification flights together with one French pilot who has done the same, one colleague. And then we were involved in a complete military team of all the 6 nations, establishing all the certification requirements, because at this time, every military aircraft has been certified to national military rules. There are some standards, but there are no rules. So we really established a certification baseline. I think it took us 5 or 6 years to get this done. And some pilots who have been in the military can imagine or know that if you go to a crisis or war, you have the possibility to accept more risk to get some things done you cannot do under civil regulations. So we had to establish for performance a reduced operational standard, which still considered engine failure. And the last one was a military operation standard, which would enable something like doing evacuation of people or really crisis or wartime operation, where you don't even consider a loss of an engine. And all this stuff had to be written down with the 6 nations, UK, Spain, France, Germany, Turkey, and Belgium and Luxembourg as one nation together.
Wow.
And so that was a great chance.
Yeah, and I know, so you spent, was it 10 years? So 10 years of your life with this baby. It quite literally is your baby. You helped this thing come alive, documenting, test flying it, certifying it, bringing it into the air forces. I mean, we had the opportunity in South Africa, the South African Air Force signed for, I think, 8 of them. It didn't work out in the end with the delays and the costs, etc. But certainly looks like a wonderful, wonderful machine. Tell us a little bit about this. There's some specific things about it. I mean, it's got air-to-air refueling. It can be refueled. But you mentioned the other day, and we didn't get into it too much, the low-level flying and the control laws. It's an Airbus, but it's got specific control laws. So tell us a little bit about the low-level flying capability of this aircraft.
So from the nations, it was a development contract. So we set up a specification, and Airbus had to design through a specification. Usually Airbus designs to customer needs and see what they can sell most on the market. But in this case, we established a capability which we wanted to have, which said we wanted to fly military low-level flight in IMC down to 500 feet. And this is quite challenging because you can. The next challenging factor was we did not want to have any forward-looking sensor. So if you look at the Tornado, who is able to fly 100 feet, it has a forward-looking radar, and it provides your terrain clearance by radar. And we had to do that only on GPS and terrain. Sorry, I missed a word. And
these are about the EGPWS.
Terrain navigation, yes.
Okay.
And this is a huge challenge because at the time we are talking about the year 2000 and even earlier, when this decision was taken, the computers were not on the standard what we have today. And development in navigation, in GPS navigation, in the possibility to calculate positions, we had a huge improvement. And we are now at the stage this year, if we are lucky and we can manage, we are able to certify 500 feet IMC fully automatic with the A400M. And you have to remember this aircraft weighs above 100 tons. So it's about the tactical landing weight is 120 tons. It's huge. And for that, the flight control has to be specific. You have to calculate a safety corridor. This means when you lose really one of the sensors, you have to be able to escape safely. All this has to be calculated. So you have always a 30 seconds period in front of the aircraft, which gives you a safe escape route, no matter what the terrain is. The autopilot is capable to 45 degree of bank to follow this trajectory. In manual laws, you are not limited like a civil aircraft, which is limited to 66. The A400, you have seen it in the video, is limited only to 120 degrees of bank, which means when you cross a ridgeline or do something else, you really can overbank the aircraft and let it drop somewhere. This was a requirement not to be limited. Maybe it's a bit over the top for the real operation, but it's a nice feature to have, especially for air shows.
Yeah.
And one funny story, when we tested initially the low-level flight, of course you check, you can follow automatically this corridor, but sometimes you want to do a manual flying when you have visual with the terrain to fly a little bit outside. And the capability of the autopilot was 60 degree at this. And when you do a rejoin to this route and you fly, you imagine the autopilot is going in 500 or 600 feet above the ground, a 60 degree bank, and you're not touching anything. This was scary. It goes very fast. And if you imagine doing this in IMC, this could be really a little bit disorientating. So that's why we decided to tune it back to 45 degrees to make it more safe when you have to rejoin or when the autopilot has to really go around the corner with 45 degrees.
Wow, okay.
But it's an amazing feature.
So it sounds like a wonderful machine to fly, to experience the capability of it. But again, the human factor is the bit that you've brought it back to within acceptable limits. It's not the equipment that is limited, but it's to consider the crew. So let's just spend
exactly.
Let's just spend a minute there on crew. I'm going to put a picture up of the telemetry room, and while you're in testing, there is a picture of a very serious-looking people, very smart-looking people looking at the computer screens, lots and lots of them. This is the telemetry room. So talk us through what a test flight team looks like. You get airborne in your team of about 6 on board with lots of computers and sensors. But there's a massive team on the ground, 20-odd people on the ground. Tell us about your telemetry team.
So this team was, of course, exceptionally big, and it was a picture from the first flight of the A330NEO, which was my first project, and when I joined Airbus. And the capability, what makes the flight test, and I think it's the same for all aircraft manufacturers in the world, when you have to be efficient, you need a lot of data to be transferred to the ground. And Airbus works the way that we have all specialists from the topics who could be an issue for the flight are available in telemetry, or they are available via teleconference or something else. And for the first flight, really all expert, handling quality, automation, for landing gear, for brakes, whatever you have, are available if something goes wrong to support online. So a first flight is quite exceptional. But usually when we do test flight, the telemetry is always there. So it doesn't matter if we fly over the sea in Italy airspace, if we go down to Spain, we have the capability. If we have some antennas, one in the UK, 2 or 3 in Spain, of course several in France, that we can cover everywhere in Europe our flight test with the telemetry. And usually these people analyze the data we produce. So for example, if we do a stall test or any test, they have a real-time data. And before we move on to the next test point, say, check the data if they are valid, if we met all the conditions. For example, in some areas you need very calm weather conditions, and they check if the traces and the data are correct, because we try to do everything in flight test which can be done immediately and be used for certification. We try not to duplicate the test. Sure. And therefore the telemetry people are an essential part of efficient and safe and valuable flight test.
Wow, it sounds like quite a complex arrangement. So you not only have real-time analysis of the data, but you've got real-time processing and feedback to say, well, that test was good, let's carry on, or we missed something here, or that didn't work out too well, can we rerun that test?
Exactly. So we have the specialists, of course, the real deep analysis for some data. If you do a performance test, sometimes takes up to 3 weeks. 3 weeks, because it's huge amount of data. But to get a first glance, if the surrounding beginning conditions, if everything has been done properly, if the condition of the aircraft, flap setting, etc., everything is correct, they can check and see if the data are really good. Maybe something happens you don't know. So the setup for us in test, we have a fully qualified team, of course, in the aircraft, which is 2 pilots. In our prototype, which are quite different condition and status from a certified aircraft, we have experimental software, we have different configuration on flaps or something else. We have a so-called test flight engineer. He's a qualified test engineer, and he is responsible for the prototype. And he knows every deviation from the aircraft, and he produces with his colleagues a so-called deviation list. And so before we go flying, we have a briefing for the flight, and in this we review this list, and we know exactly what is the condition of our prototype. And then we have to see if it's in line with our test, so that's done. And then we have the test flight engineers. They have a station with all the screens, with printers. They can see all parameters. They have a video screen from our cockpit. If we do a flutter tests, they have, of course, videos from the wings and everything else, so they can monitor everything on board, additionally to the telemetry people on ground. Oh. And very often, if you try to see, can we do an additional point? One of the rules in flight tests is you only do what has been briefed and what is in a test order. But sometimes you see the test order was not. We did not put any point down, and then the decision is taken with our engineers on board and the telemetry people, where the design office is available and gives us a clearance if we have to increase our test order. So this is a real efficient way of working, and it's a real safety feature for us, because sometimes we miss something to reconfigure the aircraft or something else, and the people on the ground, since they have less workloads, they are not flying, they have sometimes the capability to see mistakes where we miss it. So it's a real safety feature and a real teamwork as well.
Okay, and there's quite a big team that's going on the ground, and the documentation that goes with it. I mean, I just did a very little introduction to maintenance test flying and operational evaluation. You fly a little bit and you do lots of writing after, the reams and reams of paper coming through. But okay, so we touched on, you were involved in the Airbus A400 project. And over 10 years, eventually the latter part of the project, you end up spending a lot of time at Airbus, and that paved the way for your transition then into Airbus as an Airbus employee now. So after a nice career in the German Air Force, you joined, was it 2013? You joined 2014. You joined Airbus as a test pilot, and then you transition. And of course, all test pilots at Airbus have to fly all the aircraft. So what was that like, joining the Airbus family officially?
Well, that's quite challenging at the beginning. So another anecdote from when I joined, when we started flying A400. So the project started in 2003, and the first flight was finally in 2009. So I flew a little bit on Transall, and to get familiar with Airbus, we made a type rating on the 320 in 2008 to get prepared for Airbus philosophy, cockpit philosophy, and stuff like that. And then in 2009, they did the first flight, the first development flights, and I think beginning 2010, it was the first certification flight. And then we came in, we knew the people from the meetings, of course, and from working with them. And I asked one of the engineers, he could send me the test order 1 or 2 days before, that I can read through the test and set my mind up. And the guy said, hey, you're a test pilot, you're being paid for that. You get the document in the briefing, and then you get along with it. This was my introduction to test flight, which was quite scary at the beginning. But at the end, you get used to it. And of course, it's not the right way to do things. And today we focus a lot that we get test orders 1 or 2 days in advance, that we can really go through it, because it's a safety step. Sure. When I joined Airbus, I had already sent the 320 rating, and I had about, I would say, 400 hours on it. I had accumulated about 800 hours on the A400M in certification. Mm-hmm. And the A400M is a lookalike like a 380, which just more screens. So the architecture is the same. So the transition to all the other Airbus was quite quite easy because the philosophy behind is exactly the same. I always, when I do lectures at university, I make the example. The 330 was built about 30 years ago, and we have the same type rating as a 350. So pilots who've been trained on a 30 years old aircraft have a very small transition only to go on a 350. So it's a differential course which is not long, and we have no problem to follow that. You have to, of course, to learn the new features, but the basic principle how you operate the aircraft is the same.
Sure. Okay, well, let's just talk a little bit, and I'm going to put another picture up of the A400 with the flares. So this is one of the, I mean, it's a great photo with all these flares. One of the capabilities that you were involved with there. Tell us about has there been some use of this? How has this played out according to the plan? You know, the flares and in a defense role there. It's a military aircraft after all.
Well, it's a military aircraft, and first of all, our self-defense system was always delayed because this is something quite critical to the nations. And despite it's a common aircraft, some nations decided to put some features which they have already on other nations in their on other aircraft in their nation. So it was a little bit complex, but of course, an aircraft like any military aircraft who goes in the theater needs to be the capability to dispense chaff and flare, so to work against radar or heat-seeking missiles. And the interesting part is when you do something like that, you have, of course, your dispensers, and you have to make sure that the trajectory of these nice things, what you see going out there, do not hit the structure or do not cause damage. So there's quite an adjustment on the trajectory because you have to prove it in the whole speed domain. So quite some flights involved until you get it right and everything properly adjusted. And finally, to make sure when you fly in icing conditions, you're still able, with remaining ice on the dispensers, that you can safely dispense the chaff and flares. So some interesting flights has to be done in real icing condition to build up some real ice around the dispensers. And this it's always challenging. When every pilot tries to avoid the thunderstorms and icing conditions, we are asking radar to go in this area and circle around until we have to build up.
Well, that's interesting. Okay, so now you've had your baptism of fire. You are now familiar with Airbus, and you've joined them now full time, and you get involved in flying all the aircraft, and then particularly the project involved with the A330NEO, the 800-900 certification. But I just wanted to play a bit of an Airbus commercial video here now as the Airbus A350-1000 was getting certified. You were involved in that a little bit too. Let's have a look at this. There's some cheers as you get airborne for the first time in the 351,000. Thomas, I mean, it's a wonderfully made promotional video there by Airbus. But so many different aspects of it. I can remember my visit to your final assembly line with Robert in November last year. It's a beautiful thing to see this airplane being built. You had that the transporter coming into the fuselage, the people testing the undercarriage going up and down. Even the detail of the painting of the fuselage. It's a special thing to be involved with creating that first ever aeroplane.
Definitely. I think even for the people in the production, it's something interesting to be involved, because especially the first one, which is used as a prototype, has many differences to the normal standard airplane. So you have to have prepared for the flight test instrumentation, all this stuff. This is just amazing for everybody, and you see on the picture the rollout is always something big when the final assembly line pushes out the aircraft, and especially if it's the first one of a type like the 350-1000. Then after the painting, because it will be one advertising plane for some time, the painting is always very important. On the 350-900 we have this carbon-like painter, which was very nice. On the 350-1000 we stayed to be more conventional with just quoting the numbers that you can see that. It's quite amazing to be part of that. That's really good.
Yeah, there's some questions coming through in comments. You're welcome to please post your questions. I thought this is a good time to bring up. Thanks, Rodney. So he says, plan to fly, fly to plan. How much is testing and refining each aircraft that you fly, or is it mostly routine and system checks?
It depends where you are involved. We have all kinds of tests, and this makes it very interesting to work at Airbus. So as a project pilot, of course, you follow the program a little bit more on the administrative side, but you're involved in all the critical tests. So you do the simulator preparation for handling qualities. You do all the failure cases for handling qualities and other critical stuff. You're involved in system testing as well. And usually we start with 2 or 3 pilots being the core of a team for one project, and as soon as we have a certain experience, we try to bring additional people in. And after, let's say, 1 or 2 months, nearly all of our test pilots are qualified on a new product, even on a prototype, and then we share the workload to really have opinions. For example, if you tune flight controls for a flare law, not everybody has the same feeling. That's why one of the reasons we have people from fighter background, airline background, military transport background at different ages, and everybody contributes to that to make the best tuning at the end, and then you come up with 5 or 6 possibilities, and then the small group of project pilots decide which one is the best. But at the beginning, everybody can contribute, and this makes it quite interesting. Of course, if you do engine tests and you fly for 5 hours, just the autopilot straight ahead to get engine stabilizations, this is not the most challenging one, but it's part of the job, and you learn a lot about the engines, the things behind, where are the problems, and so it's both. It's not only the challenging stuff, we are system testing as well. And for me, the most challenging one is if you do radio tests. So because with radio, you have to check the range. So you have a guy, our radio specialist, he's doing the talking. So you fly 150 miles usually outboard until you lose the track. So sometimes it's 170, sometimes it's 200 miles. Then you turn around and you fly inbound until you get the signal back again. And he's talking permanently to see when he loses the signal with some station on the ground. So you're sitting here just flying outbound, inbound, sometimes 6-7 hours.
Wow.
But it has to be done. It's part of the business.
Yeah, it's all part of the business. You're right. I'm going to put a picture up of your flight test team here. Keep your questions coming, folks. I'm going to get to them now. But there's a picture of the 6 of you in front of the A330NEO. And you're in these bright orange overalls. You mentioned earlier there's 2 pilots. You got a flight test engineer and other test engineers as well. What's the reason behind the orange overalls?
Well, orange overalls are part of the safety cultures, and whenever we do some critical tests, we have all our tests are classified in 1A, 1B, or something else. And as soon as you have something classified 1A, which is a critical test, we wear the orange suits, because first they have a better fire protection than just civil clothes and shirts. And the other thing is, if something happens and you crash, it could be a takeoff or something else, even if it's not a fatal crash, people would be be found much easier by the rescue team. And this is the reason of the orange color. And additionally, flight test color is orange. Whatever is changed in our prototypes, if we have additional cables, hydraulic stuff, everything which is flight test is painted orange, that you identify quickly. This is not standard stuff, this is flight test stuff.
Okay, well, that makes a lot of sense. All right, so that comes in line with one of the other questions coming here. And Willem is asking, when you're flying a new airplane for the first time, at what point do you decide that this is the limit, whether it's the speed or flight control? How do you know where that limit is? Obviously, this would probably be classified as 1A. Obviously, there's computer modeling beforehand, but in the flight itself, how do you find the end? Where's the edge?
So what example could we use? I think a flutter testing. A flutter testing is there that in earlier times, flutter testing was done that people were flying at a high speed or a design speed, and they used a big hammer or stick and hit just the stick to excite the ailerons or whatever you need. Nowadays, this is done by our actuators. So what we have to prove and what is calculated in simulations and with a lot of experience behind, at what frequencies our structure could have a resonance, which could be danger to the aircraft. Usually it's in the very high speed regime. So we fly the aircraft outside the normal envelope. So if you know 350 is cleared for Mach 0.85, that's the normal number. And we are flying this up to Mach 9.2. Outside this envelope. And then we have an injection of some stimuli on ailerons or whatever what has been defined by the team, and we see what is the response of the aircraft. And of course, a baseline in flight test that you do an incremental approach. We start at slower speeds, we do a pre-test, we know what's going on, we do the simulator first to see if our flight controls are properly working. So it's really a build-up approach from wind tunnel models, the computer models, then you run simulation on test benches, then you do a test simulator. Our development simulators host the real hardware and the real software we are going to fly on the prototype, and then we go to fly and do a stepped approach. So first we would do the first test at Mach 0.8 in the middle of the envelope. And then we go further. And as said before, we have the team who is responsible for this test on the ground in telemetry, and they analyze. And sometimes between the two test points, in critical tests, there are 5 to 10 minutes to give them the time to analyze where it is. And only then we extend. And sometimes we go to the limit, sometimes we have to step earlier. But the experience in Airbus showed, and I think it's the same for every manufacturer, the computer models are very good now in predictions. So we very rarely detect some deviations, especially not at boundaries.
Okay, well, that's a nice, thorough explanation. Thanks, Thomas. And I like the approach to incremental gains. You test it out beforehand. You've obviously got a plan. You test it on the simulator, and you take it up stepwise. That's a great approach, and thanks for that answer. Another question that's coming through from Patrick, who says, it sounds like a small error for margin. How do you ensure that all the thoughts being put into the into these safety mechanisms don't break down in practice?
I think it's the same as everywhere. It's a chain of safety measures. And what I mentioned before, for example, the flight test order. Of course, the engineers are sometimes under pressure and produce it in the last minute. But for the pilots to read it, it's not for our pleasure or comfort. It's a part of this safety net that we can read and possibly detect problems or can ask questions. If you have a 1-hour briefing and just read it through the first time, you don't have the time to think about. With experience, most of the time it works, but it reduces this barrier in the safety. So if you consider all the people who sit in telemetry, they are part of the briefing as well. So we have sometimes a briefing room full with 20 people, and they follow exactly what we discuss. And a test order is gone through step by step. We start with the weight of the aircraft, with the configuration, with the CG, with the calculated speeds, with the limitation of the aircraft. All this stuff is briefed in detail, and then every test point is briefed, and everybody can ask questions. So even the telemetry people, if they have a question about how we do the test, it will be asked in the briefing. And we only leave once we are finished there. And so we make sure that every step we have set up in our process works in the sense to conduct a safe and efficient flight test. But safety is always first.
Okay, thank you. So it sounds like the team is a real team. You know, that everyone has their responsibility and everyone has their part to play, and everyone is able to say, hang on, I don't understand this, or maybe we should stop the bus and talk about this a bit more. So I want to bring out an aspect about your team. It's a wonderful story that you've shared earlier. So here's a nice picture of your team in a bit more relaxed mode, and there's lots of instruments. So tell us what's going on here with the flight test team at Airbus. I see a bunch of musicians.
Yes, that's what we figured out a few years ago. So one had the idea that we could do something to bring the team together. So to understand, the flight test team is sitting in one building. This is the pilots, the test flight engineers, and some maintenance guys. But telemetry people, they are in another building, which is approximately 400 meters away. So we don't see each other except the briefing. People from analysis, we rarely ever meet. And so we have a barbecue where 500, 600, 700 people can meet, and usually it's a Friday afternoon in summer. And then we said, okay, we should do something. And some had the idea we make music together. And we really figured out we had, you see, it's quite a big bunch, and that's not even all musicians there. And we played some rock music, of course, some AC/DC stuff, the standard ones, Lynyrd Skynyrd. And we had some jazz musicians as well who are playing in a big band working at Airbus in flight test. And all the people you see are flight test. And since I think it's the third year now, this year we don't know if we can do it. We will see maybe after the summer break. We will see how all this develops. We get together, we get 3 or 4 practices, and then we have a set of songs. The first year we had 1 hour in total. Last year we had 2 sets of 1 hour, so it's improving and it's a lot of fun. And you see people from a completely different side, and it makes life afterwards much easier. What I have to say that pilots have not the best recognition in Airbus from history, because it was always a top-down, pilots at the top and the other down. And this is not the case anymore, because a teamwork is really everybody plays his role and everybody can speak up. And with something like that, they see that even pilots are normal, they make mistakes in playing music or have fun doing that. And this was a great experience, and it really helped a lot, and it's good fun, and we try to keep that as much as possible.
Oh, wonderful. Sounds like you started, well, the guys have started a wonderful initiative there, and I hope it continues to have these opportunities on the downtime to just spend time with the team once again. So it looks like there's an opportunity there to be the Airbus Flight Test Touring Band. You can do a road trip through Europe one day with your touring band.
Maybe we can envisage that, yes.
Oh, wonderful. You sent some lovely photos here. I don't think I'm going to get through all of them, but here's another nice picture of the A330NEO, the 800. It's on rotation, and tell us about what's happening with this tail strike plan at the end, the back of the aircraft.
So we are talking about a VMU test, so that's the minimum unstick speed. And this is a test every aircraft has to do for certification. It means it's the slowest speed the aircraft can ever take off. And sometimes it's geometry limited. This means you start rolling, and at one speed you pull full back on the stick until the aircraft rotates. You bring the tail on the ground, and in this attitude you have to lift off. And obviously the aircraft cannot fly at lower speeds. And this is something we have to determine, because the lowest speed, the VMU, is part of defining your takeoff safety speeds and all this stuff afterwards. And the interesting part is, as I said, for certification, you have to put the tail on the ground, and then you're not allowed to change the attitude. And if you know, as a pilot, if you focus on one thing, you might lose sight of the other thing. So how we do that? It's a very tricky task, because one is focusing on the pitch only. The engineer, which sits in the middle, is focusing on the thrust, because you don't do it at takeoff thrust. Takeoff thrust is much too high, and you would have a much too high acceleration. So we deliberately reduce the thrust on both engines, so it's cleared by the engineer to which N1 value or whatever it is, the thrust has to be set. So the engineer the pilot flying puts first toga. And at one stage, 60, 70 knots, we reduce from toga to this preset engine value. The pilot with the pitch authority, he pulls up on the stick that the nose comes up. And then once the tail is on the ground, we can measure how much force it is. It should be around 4 tons force on the ground, and he tries to keep that. And with this attitude and a fixed pitch, he tries to take off. So we have some help. A head-up display helps very greatly, or if you have some really indication where your stick should be. But now this guy has to focus only on the instrument on the pitch. So he's sitting in a very, very low position that he's not distracted by anything else. The other guy who's sitting in the other seat of the pilot, he's sitting in a very high position because he looks at the direction. So he's keeping the rudder. It's really strange. Usually you have control of everything, power, pitch, rudder, everything. And the guy in the other seat is controlling the direction, because if you're focused only on pitch, you can have a slight drift somewhere. And then if something goes wrong, engine failure or something else, the pilot who is looking outside immediately takes over. So this is really a completely different task sharing to what we are used usually. And of course, we do all the tests first in the simulator. We test engine failures at different stages, low speed, when we just airborne, because when you have a lower thrust on both engines and lose one engine, you have to push the other one to toga, or to a maximum value which is allowed, and then you are behind the power curve. That's clear. You're flying below any speed any pilot in the world will see on this aircraft, and this is really one of the critical tests with a complete different task sharing close to the ground. It's challenging. You do a lot of practice for that, and this is a real team effort. The engineers in the back on the screens are monitoring all the parameters, and everybody is, of course, on the interphone. Everybody can call to stop the test, and then it's fly safe or stop safe first, and then we discuss later. So there's a lot of discussions, simulator work, focusing on the different task sharing, and this is really challenging.
Wow, Thomas, I mean,
and it produces nice pictures.
It does, and we've got a video clip. I will show the clip in a minute now of some sparks that fly too. It just sounds so fascinating, the behind the scenes look at the life of a test pilot. I mean, I think when people think of test pilots, certainly my first response is maybe you think of a fighter pilot, a Top Gun, Maverick, but so many interesting things that are going on behind the scenes at an airliner manufacturer. And wonderful insights from you. Thank you. Let me just put that video clip up, the second half of that 350-1000, and you'll get that takeoff test there again.
Of course.
Oh, nice video clip there with showing the sparks there, the snow, the northern lights. I presume you take this airplane to all sorts of different conditions. Tell us about some stories you have taking it somewhere, a high altitude, or what are the different things that you've been involved in testing this in different areas and aspects?
Well, high altitude, that's more an engine test and a performance test, because at high altitude for landing, for example, you fly much higher true air speeds. And usually we do this first in Cochabamba, which is about 8,000 feet high, and then we go to La Paz in Bolivia, which is about close to 14,000 feet. And it's a good test environment, and for certification we have to do that. As soon as we want to clear and certify the aircraft up to the high altitude places, we have to go there and see what the engines and the aircraft is doing. So I've done this with the A400M as a certification pilot. On a civil airplane I did not do that. I gave some chance to my colleagues as well. And cold campaigns, yes, we have to certify everything in all environments, hot and cold. And cold is interesting more for the systems, because you put the aircraft 24 hours completely outside, and we try to find something minus 35, 40, as low as we can get. And then the next day, everything has to be able to start. So the screens and everything, and sometimes it takes some time. And then you have to show that you can go flying, then you don't have leakages, because all the seals at the low temperature might not have the same performance as at a higher temperature. All this is interesting. But flying wise, it's you just go flying. You don't do specific tests there. It's more engine and system test and sealing test. The more interesting stuff comes what you have seen, the VMU test or the one with the water spraying. You have to make sure that when you have standing water somewhere, you don't have any damage on the aircraft, and you don't have water in to a content in the engine which is causing a flame out or something else. So usually we go to Istres, which is a big place in south of France where the French test pilot school is as well, and the tanker base. It's a 5,000-meter runway. And usually you put some rubber bands on the runways that you can fill up to 20 centimeters of water. And then you have to go on a predetermined path through that. And for the A400M, when they did it, they damaged the landing gear flaps, because it's a different design, because they are very low. You have these sponsons on the side, if you remember, and they had to reinforce it due to this test. And on the civil airplane, usually, since they have all the proximate design as all the others, we never have big problems there. But we have to do the test, which is very nice to look at as well, because
Sure.
you see the power of water
Yeah.
and how much speed and energy aircraft brings when it hits or when it goes through a water puddle.
Oh, well, fascinating. I got another question coming through, Thomas, from Protejo. He's asking, with so much in-depth testing capabilities and the enormous time spent on the accuracy of the instruments, etc., is there any difference in the process that Airbus follows and Boeing? I know it's a competitor, but is there a difference in philosophy at all between the two companies?
I think on the test accuracy and the safety measures, it's quite the same if you look at Embraer, Bombardier, Boeing or something else, because from experience, flight test and from history built up in the same steps, we have approximately the same technological development, and it's just a little bit of a philosophy change. So in Airbus, our flight test engineers, they have a very general knowledge. So the handling quality engineer can do performance stuff as well, and the performance engineer is also trained on handling quality, which means they can take over points from the other subject as well, and we be much more efficient. So we fly only with 2 flight test engineers, sometimes an additional engineer for engines in the back, and our test flight engineer. And in Boeing, sometimes they have more people in the back for the specialists of the subject and change in flight. So this is a small difference, but on the planning, on the pre-planning of simulators, how you do flight test safety, how you involve people, I think there's not much difference. And all manufacturers have a flight test safety workshop every year, not this year, according to Corona, but usually they meet every year to see what standards we follow, what we can do better, how we can do certification easier, how we can improve safety in flight tests. So there's no competition on this one. There's a real work together on flight test and flight safety.
Okay, that's great. Good to hear that the collaboration, I mean, it is the apex of the aviation industry, developing new airplanes and making them safe, making them better, faster, more efficient. It's been wonderful chatting with you, Wilhelm and Thomas, and I wanted to just leave you with one last question. You are now in charge. You're the local chief test pilot in the Toulouse campus there. You now head up the team there. What are your tips to create a high-performance team?
Oh, that's difficult. So for me, one of the things which is essential to become a test pilot, or in the job as a test pilot, and I think this is valid in every business, and that's how I've been brought up, that you are able to tell what you see. You are not forced to talk bullshit. And this is valid when you want to build a team. You have to be transparent and you have to be honest to the people. If there's something which is not positive, or you have to say something, make the point, but don't make it against people. You have to be honest, but you have to be a team player. You have to value every input, because when I say the team is important, it doesn't matter how clever you are or how much you earn. You have to play a role. If somebody is working in flight test, he is there because he has an experience, he has something to bring. And the main point is you are honest and value people, and the people have a atmosphere which enables them to speak up. And if they have a doubt, they should be able to express it. And I think that's key in aviation and even more in flight tests, because you have much more participants. And that's what I try to do in Airbus when I started to lead the team. Well, my predecessors did something the same, but to show everybody his value and his contribution. It's very easy when you have this education. You have a degree. We have people being astronaut. We have people with experience other people don't have. But that's no reason to look down on people. And this is something very important if you want to build a team.
Well, thanks, Thomas. Thanks for those insights. It's been wonderful chatting with you today. I really appreciate your time. I know you've got a busy schedule ahead. So thanks so much for pulling back the curtain and sharing the insights of what it's like test flying, brand new aeroplanes. It's been a wonderful conversation, and I hope to meet up with you at some point in the future.
Yes, thank you very much. It was a pleasure for me as well. Take care.
Thank you. Well, folks, it's been a wonderful chat. Thank you for joining the show. It's a long one, an interesting one. Thanks for all your questions. You can continue to add questions to the show. If you're not watching it live now, please remember to support the show. You can subscribe, you can like, you can share, and remember to stay safe. We've got another exciting one coming again tomorrow. Till then.